So Crew AI, unfortunately, is not suitable for production. And I'm going to explain to you why in this video. So I've set up a multi-agent workflow in Crew AI to answer multi-hop questions. I've done a similar thing in AutoGen. So I've got a previous video that will be linked in the description to this video. You can check that out if you want. But it's going to follow the same type of logic. I'll walk through the Python code, and then I'm going to demonstrate how the workflow works to answer some multi-hop questions that I've pulled out from a research paper. If you like this content, subscribe to the channel, give the video a thumbs up, share it. If you are using Crew AI in production and you disagree with me, please comment below and tell us how you're using it. It will be really interesting to find out your opinion on that. If you've had any experience with Crew AI or AutoGen, comment below as well. I would love to know what your experiences are with these frameworks. If you stay tuned to the end of the video, I'm also going to give you my opinion on where I believe these multi-agent frameworks are headed in the near future, and what I think you should be doing if you're trying to build agent workflows in production. All right, so now that we've covered that, let's get into the technical details. All right, so before we jump into the Python code, I want to do two things. I want to show you, first of all, what multi-hop questions are, for those of you that don't know. And then the next thing I want to show you is the schematic for the agent workflow that I've set up in Crew AI. All right, starting with multi-hop questions. There's a research paper that I pulled. I'll link to the research paper in the description for this video. And this is where I've gotten these multi-hop questions from. And the reason I've chosen multi-hop questions is that they are designed to be challenging to answer. And here's the reason. What you can see here is that to answer a multi-hop question, you need some preceding knowledge to then go on and actually have the information required to answer that question fully. So let's take the first example. Who succeeded the first president of Namibia? Okay, so that's a two-hop question, and you can see that under the decomposition here. So to know the answer to that question, you first need to know who was the first president of Namibia. In this case, it was Sam Nujoma. And then once you know that, you can then go on to answer who succeeded Sam Nujoma. So you can't answer that question without knowing the first question, right? So you can't answer the question in full without knowing the answer to the first decomposition or the first breakdown of that question. And then you can answer that question in full. So in this case, it's just two hops. And this is the simplest variety of multi-hop question that I have today. And you can see this by the graphical structure as well. So it's represented, each question is represented by a node, and it's linear because you need to know the answer to the first question to then answer the second one. And then it can get more complex. So we have a 3-hop question, and it's linear again. So the question is, what currency is used where Billy Giles died? So if we look at the decomposition of this question, it's obvious, first of all, that we need to know where Billy Giles died. So at what location did Billy Giles die? And that's Belfast. And then we need to know what part of the UK is Belfast located in? And that's Northern Ireland. And then what is the unit of currency in Northern Ireland? And that's pound sterling. So that's the 3-hop question. And I'll just add a side note here to say that we don't necessarily need to do this in 3 hops. This could probably be done in 2 hops, because once we know at what location did Billy Giles die, Belfast, we simply just need to know what currency is used in Belfast. We don't necessarily need this second part, but this is the example they've pulled for a 3-hop question. And hopefully you get the premise of this. So multi-hop questions don't have to just be linear. There is an example here where you have a multi-hop question that has 2 parallel decompositions represented by these nodes here. So let's look at the question. When was the first establishment that McDonaldization is named after open in the country Horndine is located, right? So the first decomposition is, what is McDonaldization named after? And the answer to that is McDonald's. So let's take that as the first node here. And then the second node here is unrelated to the first node, actually, because the second node relates to this decomposition. Which state is Horndean located in? So you can see that has nothing to do with the first one, and that's why these are not in series. These are parallel. And the answer to that is England. So now that we know the answer to question 1 is McDonald's and the answer to question 2 is England, we can then go on to answer the third question, which uses those two. So this is where it is in series now. It uses the two previous decompositions. And that question is, when did the first McDonald's open in England? So if you go back to the original question, when was the first establishment that McDonaldization is named after? So we know that's McDonald's. Open in the country that Horndean is located, and we know that's England. So that relates to this third question. When did the first McDonald's open in England? And the answer is 1974. And you can see that the multi-hop questions do get more complex as you go down. So when I was doing this with AutoGen, I did test all of these, I think excluding the first one. And I'll do the same with Crew AI. I'll see how far I can get testing these and see how well Crew AI performs in answering these multi-hop questions. Okay. Hopefully multi-hop questions are clear to you. If it's not clear, you should pause the video here and just go in and have a read of that research paper yourself. Or you can pause the video and just simply review this slide. Next, I'm going to talk through the schematic diagram that represents the agent workflow that I've built in Crew AI. Let's look at the schematic diagram that represents the agent workflow that I've built in Crew AI. So it's quite simple. You have a user query that comes in, obviously, and that will be a multi-hop question of the variety that we just discussed. And then the first step is actually a planning agent. So the job of the planning agent is to take that multi-hop question and break it down into those compositions that we saw earlier. Obviously, this is an important step for answering multi-hop questions. So that's why we have that planning agent in there. So that's the job of the planning agent. Just does one thing, takes the multi-hop question and breaks it down into those compositions. So for example, what currency is used where Billy Giles died? The planning agent would identify where Billy Giles died, and then secondly, identify what currency is used where Billy Giles died, which is Belfast, obviously. Okay. So it's important to note that the planning agent doesn't answer those questions, actually. It just breaks it down. So it just gives us the composition. The next agent is the search agent. So the search agent takes those questions that are broken out by the planning agent and then uses a combination of tools. So there's a web search tool and also a tool to actually visit those websites that pulls up in the search engine results page and get information from there. So using a combination of both of those tools, the search agent can find the answers to those question decompositions outlined by the planning agent. So that's the job of the search agent. Once that's done, that's fed to the integration agent. And the integration agent, the job is to organize the information returned by the search agent and also provide feedback. So if there is something missing, if something is missing from the search agent, the integration agent will provide feedback, and that feedback is also based on the user query. So all the agents know what the user query is. So the integration agent provides feedback to the search agent, and hopefully the search agent goes back and refines its search and then returns it back to the integration agent. All the integration agent is really doing, other than providing feedback, is organizing that information. I have also told it to organize the information alongside the sources too, because that's going to be really important to understand the source of the information. So that's the job of the integration agent. And then finally, you have the reporting agent. The reporting agent simply synthesizes the information from the integration agent into a coherent response that can be delivered to the user. And, I have given the reporting agent the prompt to also return sources and citations. I did this in AutoGen, and the workflow did seem to work in AutoGen for a number of questions. I think only the most complex multi-hop questions it struggled with, but I was even able to get citations and things in AutoGen. So it'll be interesting to see how Crew AI performs with this same agentic workflow. That's it. Pretty simple. Hopefully that's clear. Again, feel free to pause here and just review this. And the next section, we're going to go on to look at the Python code for the Crew AI. So I'll talk to you a bit about how you set up the Python script in Crew AI. I'll talk to you a bit about the concepts that Crew AI uses to build its multi-agent workflows. The GitHub repository that contains all of the code is linked in the description to this video. So feel free to go into that and download it yourself or clone it or whatever, and you can freely use that for your own agent workflow if you wish. All right, so I have the Python script for my Crew AI agent workflow open here. Let's just talk a few things about the setup. So there is this config file here. And if you're using this for yourself, you'll need to go into the config file and you'll need to provide API keys. So I'll show you the API keys. And don't worry, I'm going to get rid of these before this is live. So these API keys will be refreshed before this goes live. So you have the SERP API key. You'll need to get one of these. I'll link you to the website where you can get this API key for yourself when you want to do this. And obviously an OpenAI API key here. So all you need to do is update this here, and the script handles everything itself. So it reads these into environment variables, and that's how Crew works. It works on the basis of assigning these API keys to the environment variables. And you can see that done here in this load config function. So that's how your API keys are assigned. This is actually not necessary because we're not using an inference server here. We're just using the OpenAI API. So I'll comment that out. Okay. So I'm using GPT-4 Turbo. I have tried this with GPT 3.5 and I found the results to be substandard. So GPT-4 Turbo is the model choice here. And I would probably advise you to use GPT-4 Turbo if you are working with multi-agent workflows. I just think the models that have come before that aren't necessarily capable enough in terms of their reasoning abilities to work well with multi-agent workflows. So I'm using GPT-4 Turbo for that reason. Temperature set to 0. We want this to be, we don't want it to be creative. Basically, we want it to be as deterministic as possible. A, so we can get repeatable workflows, and B, we want it to deliver the most probable output. So we don't want it to be creative. We don't want it to deliver anything that's kind of like a wild card. So for that reason, I've set temperature to 0. And I think for most agent type workflows, you will be working at a temperature of 0. All right, so let's talk about how Crew works itself and the different wrappers they provide. So the first one is the agent wrapper. And agent wrapper, I guess, is pretty self-explanatory, but I will talk about some of the arguments used to initialize the agent. The first one is the role. So you will set your role and just make sure the role makes sense for the workflow that you're building. The second one is a goal. So this is where Crew is a bit different from AutoGen. There are kind of they give you various hierarchies of, I'll call them prompts, to determine how your agent behaves. So at the highest level is the goal. So this is almost like the executive level. And here, for the planning agent, if you remember the schematic diagram, it's streamline complex inquiries into organized and manageable components. So that's what I've set for the goal. And that aligns with the task of actually breaking those questions down and decomposing them into their hops or their sub questions so that we can answer the multi-hop question. So yeah, the goal is high level. And then you've got the backstory. So admittedly, I was a bit stumped by the backstory because you'll later on see that we also have tasks that we define. But a backstory is literally a backstory. That's how it's described. You give the agent a backstory, and that is somehow meant to adjust the agent's behavior. I think a lot of this stuff is just adding additional flexibility to how you prompt and giving a consistent and standard way to organize your prompting. So that's why they have these goals, backstories, and tasks. But I'll show you where the backstories come in. So I have created a separate module here with all the backstories. So you can see the backstory for the planner is expert in deconstructing complex multi-op questions into a network of simpler, interconnected queries. So this is slightly lower level than the goal. And it's kind of more like giving it, I don't want to say a personality, it's the wrong word for agent workflows, but it's kind of like when you put the system prompt in, I gather, when you're building a chatbot. So that's the backstory. And then obviously you're setting your LLM. There is the ability to cache as well. So I've set that to be true and to allow delegation. So I've played around with this allow delegation setting. And I'll be honest, I'm not quite sure what difference it makes. Supposedly, if you allow delegation, the agent can delegate to another agent in the workflow, which is what I want because I have feedback loops in there. I have a feedback loop between the planning agent and between the search agent and the integration agent. So it would make sense to have that delegation. But honestly, I'm not sure that turning this off had made a big difference to the results I was seeing. And that's it for the agents. That's the agent wrapper. It's pretty straightforward and, self-explanatory. So next thing you want to do is set up your tasks. And the tasks are actually giving us a wrapper here in Crew AI. And that's something that's a bit different from AutoGen. So Crew provides you with a task wrapper, and you initialize that with a description. So the description here is, the description of the task that you actually want a specific agent to complete. So you see here, right? So you have a description, and I'll go into the description file so you can see what that looks like. I've got a separate module showing all of the descriptions, and then there's an expected output. So you can define how you want the output to look. And then there is the agent itself. So which agent is this task assigned to? And obviously the planning task is assigned to the planning agent. So this description for me is like the lowest level. And this is where you provide as much detail as possible about the task that needs to be completed. So I'll show you how I've set up my descriptions. So I've got a separate module, tasks. And if you go into tasks, you can see the task for the planner, and this is the description. So there's a lot more complexity here, a lot more detail here in determining that task. And also every task has the query. So every agent is also aware of the query that it needs to answer. And I've also done, just specifically for the planning agent, I've given a little bit of in-context learning here. So I've given an example, and the example was the first question in that multi-hop question paper, which was who succeeded the first president of Namibia? And then we've got the answer here, and then we've got the decomposition. So I'm just giving the planning agent a way to understand how I would like it to break down those questions. Perhaps what I'll do actually is I'll remove the answers, because I think this kind of suggests that I want the planning agent to also answer those questions. So I will remove those to ensure that the planning agent knows that his job is just to break down the tasks and not actually answer the questions. That is for the search agent to do. So to break down the question and not actually answer those decompositions. Okay, so I'll hit save on that. Okay, so then we have the task for the searcher, and you can go into these in more detail. I'm not going to go into every single prompt in detail here, but when you explore this yourself, when you explore the GitHub repo, you can go into these in more detail to see how I've outlined all of the tasks here. So really briefly, the searcher, as the searcher, your responsibility is to conduct targeted searches. Yep. Okay. Adapt your search strategy based on the type of sub-question to be sub-question, be it factual, conceptual, or contextual, incorporate knowledge from previous searches to inform subsequent ones. Okay. Some of this is written a bit funny, so I'm going to get rid of that. Oop. And get rid of that. That's fine. Okay. Not that it would make a huge difference, but okay. So then we've got the integration agent. As the integration agent, synthesize the answers obtained for each sub-question into a coherent and comprehensive response that addresses the user's original query. That addresses the user's original multi-hop question. Okay. If you identify information gaps or need further clarification, provide specific feedback to the planner agent. Yes, that's exactly what we want. Actually, we want to provide specific feedback. Yes, yeah. So that schematic diagram was slightly incorrect. We actually want to provide feedback to the planner agent, because the planner agent can adjust its approach. It can adjust its approach, and then that feeds back into the search agent, and then we go again. So this feedback is crucial for refining the investigation and ensuring the final response is comprehensive and accurate as possible. Ensure you include sources of information in your integrated response to maintain transparency and credibility. Yes, okay, so we have explicitly stated to include sources of information. And then finally, we've got the reporter. So as a reporting agent, your role is to deliver the final integrated response to the user, ensure it accurately and comprehensively addresses the multi-hop question. Yeah. Review the synthesized answer for clarity, accuracy, and completeness. Incorporate citations for all references of information. Yes. Present the findings in a clear, concise, and informative manner, providing citations and links to sources. So we've outlined that specifically here. I'm not going to read the rest, but you get the deal. It follows, it aligns with that schematic diagram, bar the feedback bit, which was an error. But instead of the feedback going to the, instead of the integration agent feedback, providing feedback to the search, it's providing feedback to the planner. So those are the tasks. Let's step back into the app. So once you've defined your tasks, oh, apologies, there are a few other things to look at with tasks. So we've covered descriptions, expected output, and the agent that each task is assigned to. So some agents or some tasks require tools, and you can define those tools here. So I said already that the search agent needs to use a search engine results page tool and also a website search tool. So we have those tools defined for the task that is assigned to the search agent. So you can see that here. And lastly is the context, right? So the context, to me, I took this to mean the context that you want the task to have access to, and therefore the agent that's executing that task to have access to. So obviously for the search agent, we want the context to be the planning task. So we need the context to be the planning task because this is where we decompose those questions that we're going to actually go and search for. So without that context, I gather that this agent, the search agent, won't have the information necessary to search, to perform that search. So that's where the context is defined. So for the integration task, the context here is both the search task and the planning task. And that, for me, I've said it like that because I think that gives it the best ability to provide the feedback necessary, if at all necessary. And then the reporting task has everything. So it has the integration task, search task, and planning task as context. And that might not be entirely necessary, but I thought, the final stage should have a view of everything else that's happened before to provide its response. And that is pretty much it. The only other thing you need to do is set up your crew. And there's a crew wrapper here. And it's very straightforward. It's quite similar to AutoGen. If you use the group chat feature in AutoGen, it's similar to that. You set your agents. And then your process. So the process is defining how the tasks or how the agents execute their tasks. So you can have it sequential, and sequential is literally just the first agent you define executes their task, and then it moves to the next, and then the next, and then the next. I think with sequential, it's hard to build in that feedback mechanism. So what I've done is I've set it to hierarchical. And hierarchical is where you have a manager LLM that decides which agents should execute each task. And I think there, because I would assume that the manager LLM has access to everything. So it has access to all of the task descriptions, it has access to the expected outputs and all of that stuff, because and has access to the agent description, has access to the overall goals, so that it can decide which agent is supposed to be doing what thing. So that's my assumption. I haven't dug deep enough into the code base to confirm this, but feel free to do that yourself and confirm it in the comment section if you know the answer to that. But the idea is the manager LLM, instead of just executing things sequentially, will decide which agents should work to execute on the task. And then we have our tasks that we set up in the crew as well. And that's it. Then you just kick off. So let's test the multi-agent workflow that we set up in Crew AI. So before we test this, I want to show you something. So I want to show you my OpenAI API usage because we're going to track how expensive this is. So this is experimental stuff I've done before this run. So just take a note of that. We've used 19 cents of GPT-4 Turbo and less than 1 cent of embedding models. So we're going to go from that base. Anything above that is going to be the usage for this question. So we can track how much it costs to run this workflow for one question. So let's navigate back to the research paper. And the question we're going to pick out is what currency is used where Billy Giles died, right? So we'll pick this question out and then we'll go back to the PowerShell. So in the PowerShell, what you want to do is you want to type Python app.py, and then in quotes, you have your question. Yep, paste anyway. And then hit enter to run. Now, I have found that Crew AI does seem to take a bit longer to enter that agent workflow. I found AutoGen to be a bit more rapid in that sense. But yeah, that's another kind of tick against or mark against Crew AI when it comes to working in production. You imagine in a production use case, you don't want it to be this slow. Okay, so we have entered the agent workflow. And I'm going to talk through this as it runs. So we've got a thought here. And the thought says apologies, before I go into this, I want to highlight that the thoughts are highlighted in green and the outputs are given in purple. So that's quite good to give you that color scheme to differentiate between what the agent is thinking, the logical steps it's taking, and the output and the result of the actions it takes. Okay, so the thought. To answer the main question, what currency is used where Billy Giles died, I need to first identify who Billy Giles is and where he died. Once the location of his death is established, I can determine the currency used in that location. So that makes sense. So it says this involves a multi-step process where each sub-question feeds into the next. So that's correct. It's correctly identified. That's brilliant in that sense. Okay. So then we get a delegation here. So it says delegate work to a co-worker, and the co-worker here is the searcher. And then we've got a task. Identify who Billy Giles is and find out where he died. And we've got some context. The main question requires knowing the location of Billy Giles's death to determine the currency used there. Start by identifying who Billy Giles is, as this might not be common knowledge. Then find out the specific location, city and country where he died. Okay, great. So that sounds like a solid plan. That's the context. And, if you remember, we had that context for the searcher agent. The context was the planning agent. So I assume that that's what's happened here. Four. So we've got our next spot. So we're entering a new Crew agent executor chain. It's funny, between every thought, it seems that we do this. To identify who Billy Giles is and determine where he died, I need to start by finding basic information about him. Since Billy Giles is not specified as a widely known figure, I will begin with a general internet search to gather initial details about his identity. So who is Billy Giles? And then we've returned some search engine results page for Billy Giles. So the search results provide multiple individuals named Billy Giles, but the snippet from the BBC Northern Ireland website mentions a Billy Giles who hanged himself after being released from prison. This information seems relevant to the task of finding out where he died. I will read the content of the BBC Northern Ireland website to confirm details about his death and identify the location. So that's pretty sensible. That seems to make sense to me. So we've stepped into the BBC Northern Ireland article, and this is the purple output that you can see here. So we've got another thought. The BBC Northern Ireland website confirms that Billy Giles, who was involved in sectarian violence and later expressed remorse, died by suicide after being released from prison. The article does not explicitly mention the location of his death, but given the context and the website and his background, it's likely that he died in Northern Ireland. To confirm the specific location of his death, I will search for an obituary or any detailed report that might specify where he died. So this is pretty good. So Billy Giles' death location. And we return our search engine results page again. The search results indicate multiple individuals named Billy Giles, but none snippets confirm the death location of Billy Giles involved in sectarian violence in Northern Ireland. To find a more specific location, I will read the content of the Wikipedia page for Billy Giles, which might provide detailed information about his death and location. So this is good. So we stepped into the wiki page for Billy Giles, and it has returned the entire wiki page, which will be expensive because this is probably all being inputted into the context of a large language model, I would imagine. For I know the final answer. So the final answer, Billy Giles, born William Alexander Ellis Giles on September 3rd, 1957 in Belfast, Northern Ireland, was an Ulster Volunteer Force volunteer who later became an active in politics following his release from the Maze prison in 1997. So do we have a final answer here? So here we go. Belfast is the location of his death. So that's good. We know that to be correct. So it's finished the chain. So we've got this response from when the chain has been finished. So now that I know Billy Giles died in Belfast, Northern Ireland, the next step is to determine the currency in Northern Ireland. So great. So we're delegating back to the search agent to find the currency used in Northern Ireland. So we've got the context. Okay, so now we're entering a new chain. So this chain is doing the search. So we've returned a search engine results page for currency used in Northern Ireland. So that's the search query. And then the search results clearly indicate that the currency used in Northern Ireland is the pound sterling. To provide a comprehensive answer, I should read more detailed content from the reliable source. So this seems a bit unnecessary. We know it's the pound sterling, but it wants to provide a more comprehensive answer. And I'm not sure why. It seems like we've got our answer, but it's visited one of the links in that search engine results page. And again, we're returning the entire content of that website or that page. So we have a final answer. It's just confirming that it's the pound sterling. I'm not going to read all of that. And then we finish the chain. So there's another thought here. So final answer. So this is broken out how we actually conducted this investigation. So it's broken out into two sub-questions: identify who Billy Giles is and find out where he died, determine the currency used in the location of Billy Giles's death. So we've got answers to both sub-questions here. And we finished the chain. And then we've got another thought here. So we're entering another chain. I've reviewed the provided context and understand the task at hand. The main question is, what currency is used where Billy Giles died? And it has been broken down into two subqueries. So again, it's kind of repeating itself here. So we have the final answer anyway, which is correct. We'll finish that chain. So now we need to synthesize all of the information. So I'm not sure if this is the reporting agent doing this or the integration agent. But then we've got another final answer that just seems to be a bit more long-winded, actually. And then we're stepping back here again. So we're entering the chain again. So I need to ensure that the synthesized answer is clear, accurate, and comprehensive. I'll review the provided information structure in a way that's easy to understand and ensuring all necessary citations and references are included. Okay, so we have a final answer. The currency used in Belfast, Northern Ireland, where Billy Giles died, is the pound, which is correct. Then it goes on to give some information about Billy Giles, which is not really necessary, and some information about the pound as well. And then it's talked about its steps, but actually there are no citations provided here, which is a little bit annoying because I explicitly mentioned in the prompts that we should provide some citations. And it also knows that it needs to provide citations and references because it mentions it here at the top, ensuring all necessary citations and references are included. So clearly it hasn't been able to do that. And I will just say that when I did the same thing with AutoGen, it was able to provide those citations and references. So for one reason or another, it's just not doing that. Okay, so we did get to the final answer, but to me, this seems like a long-winded approach to get there. I think we could have gotten there a lot sooner than we did with this crew AI workflow that I designed. Let's take a look about the cost of answering this question. So how much did this actually cost us? So I'm going to pull over the OpenAI usage. Right, let's just have a look. So we were on 19 cents for GPT-4. So we're on 49 cents now. So it seems like it cost us 30 cents, which is quite a lot. So roughly 30 cents to run that one query. So that was quite a simple query. That's just a 2-hop, or I guess a 3-hop, but 2 to 3-hop question. And it cost us 30 cents. So honestly, I can't think of a use case that would justify that type of search cost. This is just information retrieval at the end of the day. I can't think of a use case that would justify that type of search cost. Not to say that you would use multi-agent workflows to actually answer multi-hop questions, but it is a way to kind of test the framework. Yeah, it's expensive. And I found AutoGen expensive too. So yeah, this seems kind of prohibitively expensive to me, and probably another reason why this is maybe not suitable for production use cases. Let me know in the comment section if you've managed to do this in a cheaper way. There probably are ways to make it slightly cheaper, like instead of returning the whole context of a website, maybe we do some kind of search. We do some kind of retrieval on the website relative to the actual query, but I feel like that would require a lot of customization to do that. So the other thing that I'd like to point out here is, okay, so first of all, it didn't return any citations. So that's another mark against it. The other thing is, to me, looking at this output, it's not really clear on which agent is taking on which task. So there is one place where we see tasks being delegated to a coworker. So we can see the task has been handed over to the searcher agent, which is great and makes sense at that point. But then tasks just seem to kind of progress without any type of handover. So it's not clear which agent is handling which task. And that's something that is actually quite clear in AutoGen. You can see explicitly that if you use the group chat wrapper in AutoGen, there's the group chat manager. And I think it's the group chat manager that's responsible for kind of distributing the context to all of the agents. And then you can see which agent is handling your query at that point in time of the agent workflow. So that's helpful for tracking purposes, but I can't say this is the case for Crew AI. I'm not sure which agent was handling each task. I just know roughly from the prompting what it's doing. The other thing is that it seems to at points do more searches than necessary. I like the fact that it is going into these search engine pages to confirm that the information it's seen in the search engine results page makes sense. But, if you see several sources all saying that the currency in Northern Ireland or in Belfast is £1 I don't think you then need to go and visit one of those sources to just to add some extra confirmation, and it is doing that. That seems token intensive to me and a bit of a waste. And that might be because there might be some prompting in the background actually underneath this that means that it does things like that. I don't know. I haven't looked at the GitHub repo in detail to see, but let me know in the comment section if you do know why it does things like that. But that is token intensive and makes this, running this quite expensive. So yeah, that's it for the first question. We'll try something more complex next, and hopefully maybe we can return some sources this time. Maybe it can do it in a more efficient way. I don't see how, if I'm being honest with you. I think it's going to be even less efficient for something more complex, but let's try it anyway and see what happens. Let's try something a bit more complex. Let's try one of these questions that has this parallel element to it, where we have those two parallel decompositions that we need to answer. So we'll try this question. When was the first establishment that McDonaldization is named after open in the country Horndean is located. So we know the correct answer to that is 1974. This should be a bit more of a challenge for through AI. And, given how it responded to the much simpler question before, I don't really have high hopes for this, but let's try it out anyway and see what happens. Remember the usage? The usage was around 49 cents. So we'll keep track of that. Usage was 49 cents, and we'll see how expensive it is to get to an answer for this question. So I've copied that question out. And once again, it's the same as it was before. So what you want to do is you want to run Python app.py, in quotes, you want to put your question. Make sure that is the right question. It is, and then hit enter to run. So we'll enter that agent workflow. Okay, so we've started the agent chain, which is good. All right, so we have our first fault here. So to answer the main question, when was the first, let's just scroll back up. So to answer the main question, when was the first establishment that McDonaldization is named after open in the country Horndean is located? I need to break it down into simpler, interconnected sub-questions. First, I need to identify the country where Horndean is located. Then I need to determine the first establishment that McDonaldization is named after, which is McDonald's. So it's kind of just answered this already based on its own knowledge. Okay, that's fine. Finally, I need to find out when the first McDonald's opened in that country. Okay, so we're delegating to the searcher. So this feels quite familiar. This is what happened last time. So identify the country where Horndean is located, and we've provided some context here. I won't read all of the context. So again, we're searching, and we're returning a search engine results page for Horndean country location. So we've got all of these search results. And then we've got a fault. So the search results clearly indicate that Horndean is located in the United Kingdom. So here's where, again, it's the same issue, isn't it? Horndean is located in the United Kingdom. It says the search results clearly indicate that Horndean is located in the United Kingdom, but it still insists on going into the link and actually confirming with one of the sources when it really doesn't need to. It can do that from the search results. Yeah, so this is token intensive. So we're back. We're in city population .de. So we don't even know how trustworthy this is either, but it's chosen a link to visit, and it's returned the context of that page. Thankfully, it's not that long, but it is still unnecessary tokens, in my opinion. So we've confirmed Horndean is located in the United Kingdom. Okay. So it's finished that chain. So we know Horndean is located in the United Kingdom. Now that I know Horndean is located in the United Kingdom, the next step is to determine when the first McDonald's opened in the UK. This will help answer the main question regarding the opening of the establishment that McDonaldization is named after in the country where Horndean is located. So we're again delegating to the searcher. So it's finding out when the first McDonald's opened in the UK. And you can see that search result here, and we've returned a search engine results page. So the search results provide consistent information about the opening date of the first McDonald's in the United Kingdom. To confirm and gather more detailed information, I will access the official McDonald's UK history page. Fine. So that seems to make sense. There is quite a lot of information here, but for this purpose, seems to make sense to do that. So we've got a final answer. So the final answer is the restaurant, the first McDonald's restaurant opened in Woolwich, Southeast London in October 1974. Okay. That's the chain finished. So we know when the first McDonald's opened in the UK, which was 1974, and we know that's the correct answer. So I know the final answer. So now it's synthesized an answer. And it's shown how we got to that point. So how do we get to that answer? So we identified where Horndean is located, and we identified when the first McDonald's was open. And then again, it's quite verbose, isn't it? Okay. So let's have a look at the thought. So I need to synthesize the information provided to form a comprehensive and accurate response to the user's query. The query asked for the date when the first establishment that McDonaldization is named after opened in the country where Horndean is located. From the context, I know that Horndean is in the United Kingdom and the first McDonald's were opened in 1974. I need to ensure that all details are correctly integrated and clearly presented. Okay, so this does seem like the integration agent. So stepping there. And it does provide some kind of final response. And then we go to the reporting agent. So it doesn't explicitly say it's a reporting agent, but I can tell by the thoughts. So I need to ensure that the synthesized answer is clear, accurate, and complete, and that includes all necessary citations and links to sources. I will review the provided information and prepare a final response that meets the criteria. So we have a final answer. So here's the final answer. The first establishment that McDonaldization is named after, McDonald's, opened in the United Kingdom in 1974. The specific location of the first McDonald's restaurant in the UK was in Woolwich, Southeast London. This marked the introduction of McDonaldization to the country where Horndean is located. As Horndean is situated in England within the United Kingdom, the information comprehensively addresses the query about when and where the McDonaldization concept was first introduced in the UK. For further details on the history of McDonald's in the UK, you can visit the official McDonald's UK website or consult historical records related to the expansion of McDonald's into international markets. So again, it hasn't actually provided any sources for citations, even though it knows that it needs to do that. So you can see up here that it says includes all necessary citations and links to sources. So it just simply hasn't done that. Yeah, so that seems to be a bug, really, not a feature. That definitely seems to be a bug. It's not working out. And I can't tell whether it's a bug with the way I've set up the multi-agent workflow or Crew or both, or the interaction of both. And I gather it's probably the interaction of both. But yeah, it's interesting to me that it seemed to work with AutoGen, but yeah, I'm getting it. It seems difficult to get this to return citations. All right, so we looked at a few examples of Crew AI and how it works to answer multi-op questions. Now, I'm not going to go through the remaining examples. I think you guys will get the idea of what I'm trying to show you here. But yeah, this just goes to prove my point. Crew AI, I don't think is ready or suitable for production. There's a few reasons for that. Firstly, the length of time it actually takes to execute the agent chains just feels a bit too long. You know, I could put those same questions into Perplexity, for example, and it will come back relatively quickly. You could even get direct answers to those questions now with a capable model like GPT-4. And I'll talk about another point where I think these multi-agent frameworks are going that's related to that. The second thing is the interpretability of the actual output. So that's actually worse than AutoGen. At least AutoGen, you know what agent is handling which part of the workflow, whereas with Crew AI, it doesn't seem to be clear. And again, that could be a mixture of the framework and the way I've set up the agent workflow. But yeah, it's not clear at all, as you've just seen, which agent is handling what part of the workflow, which to me is a minus there, because you know we want that to be transparent. The third thing is inconsistency. So I found this to be common across both Crew AI and AutoGen. You just cannot predict what's going to come out of the other end of that multi-agent workflow. There is probably more inconsistency that I've observed in Crew AI than AutoGen. And sometimes it just, for some reason, Crew AI doesn't follow your instructions. So, you know, we saw that when I was trying to get it to return citations, and it just didn't, even though it had explicitly noted that it must return citations. All of the things there, all of the things that were necessary to return some citations were there, available to it, but it just didn't do it. And yeah, I've had some runs of Crew AI where I can just see that it's highly inconsistent. And yeah, so that's another mark against it for production. In terms of cost, the cost is pretty much the same. for AutoGen and Crew AI. They're both very expensive to run these types of workflows. So I think that is another thing that prohibits it going into production. I can't see many use cases that level of cost is acceptable. Okay. Some of the positives of Crew AI is that it's easy to work with. It's really easy to set up a multi-agent workflow. You saw that. I think I did it in less than 200 lines of code, if you don't count all of the prompts, but it is quite easy to get things going and to set things up. I think it could be useful for experimentation and prototyping, but yeah, as I mentioned, I wouldn't put that anywhere near production right now. All right, so I'm going to talk a little bit about where I think these frameworks are going. So the short answer is I don't think these frameworks have much of a future, and here's why. Sam Altman said something really interesting. He said there's kind of two types of engineers or two types of startups, and I'm paraphrasing here, so don't take it to be exact. He didn't say this exactly, but he said something along these lines. I'm paraphrasing. He said one type builds for what the models can do today, and the other type builds for what the models will do in the future. So I think frameworks, especially these multi-agent frameworks like Crew, AutoGen, are definitely in the first category. They're building for what models can do today. Part of the reason to include multi-agent frameworks is, or to use multi-agent frameworks, is because the idea is if you break a complex task down into simpler tasks, the large language models can handle that more effectively by using multiple agents. But in the case where large language models improve to such an extent that it's just suitable for one agent, one agent can complete that task just as well as, or even better than multiple agents strung together, then what is the use for AutoGen and what's the use for Crew AI? So personally, I think that's where it's going. I don't think these frameworks have much of a future. I think they're definitely built for what large language models can do today. And in the future, we'll probably just have much more powerful models that can use one agent to do everything we need it to do. The other thing to consider as well is, if you do want to build complex agent workflows, I think it's worth building your own custom workflow depending on the application you're trying to build, especially if you're going into production. The reason I say this is you just have much more control over the prompting. So if you haven't ever dug into the GitHub repos for frameworks like Crew AI or AutoGen, I would suggest that one day when you have time, go and dig in, and you'll be surprised what you see. There are prompts hidden deep within these GitHub repos that allow the frameworks to work as they do. And those prompts, the way they're written, might not actually be suitable for your use case. So you have two options. You can customize the existing framework, which works for some people, or you can just build your own from ground up. And there you know what is in the repo from start to finish, right? So you can build a prompt that is suitable for your production use case. So that's what I would suggest. I would recommend, if you are going to build something to go into production or you're building an application, I'm not sure you should be building on top of Crew AI or AutoGen. If you need a complex agent workflow, build your own. So build something custom. If you like this content, subscribe to get more content on large language models and artificial intelligence. Give a thumbs up to the video if you agree, or even if you disagree, give a thumbs up and still comment and tell us what your disagreement is. Thank you for tuning in again, and I look forward to seeing you in the next video.